Okay, so hi everyone, good evening to all and welcome to this new session. So today in this particular video, we are going to discuss some important coding questions, which is very important for the Infosys exam point of view. So basically we already know the exam pattern has been changed and the package structure is also changed. So obviously the coding questions, level of the coding questions will not be easy. So today in this particular session, I have taken like multiple questions that is not the level of easy level. So the above easy means you can say the multiple medium level of problems I have taken in this particular session. Okay, and also I have taken the hard level problems. No need to worry. I will try to cover up the most of the topic. Fine. So before we start this today's session, let me introduce first. So I am Adarsh Gupta and I am currently working as a senior software engineer. I have around 3 years of experience in teaching as well as in IT industry. Got it? Okay. So without doing any further delay, let's start this today's session. Before that, you can connect me on the LinkedIn if you want. Like if you have any kind of doubt, you can connect me on the LinkedIn. And the LinkedIn URL I have attached here. Got it? Fine. So let's start this. The Infosys updated exam pattern for the SP and DSE. Like this is the role basically, right? Specialist of programmer and DSE. So basically the exam structure will look like this. The total question will be 4. Total duration will be 3 hours. Okay, in 3 hours we have to solve 4 problems, and obviously the level of the problems will not be easy at all, so keep in mind. So the question difficulty breakdown, so basically you can expect the easy level problem can come from array. It's not mandatory that it will come from the array topic only. So the easy level problem can also be asked from the DP, but will be the easy. Okay. And similarly, the medium level problem can be asked on the string. It's not mandatory at all, but we are expecting. Okay, and the hard level, obviously, the question can be asked from DP as well as from tree, from graph as well as the complex level DP on graph. Like that, the combination of the problems can be asked. So we need to prepare. Obviously, we need to prepare from all the patterns, from all the topics. Fine. So let's see this. Roles, compensation, trainee level, specialist programmer, that is SP, right? And DSE means digital specialist engineer. So basically, SP specialist programmer, that is L3 level, the salary will be, package will be 21 LPA. This is very good. This is handsome package. So for the SPL2, like specialist programmer L2 level, the package will be 16 LPA. Like these things already discussed in the previous multiple YouTube sessions, right? Pratik sir also mentioned multiple times. So I hope everyone aware about this. So this is the motivation. This is our motivation to study hard, to solve more number of problems of the DSA, right? So 10 LPA for the SP L1 level and this much amount of joining bonus as well, 1 lakh. So for the DSE role, the package will be 6.25 LPA and the 75,000 as a joining bonus. So this is huge. Like it's a good package, right? Okay. So now after this discussion, let me tell you, we have launched the Achiever batch, our Achiever batch 2.5. Okay. So let me go through that particular section. So basically, just see this. This is our Achiever 2.5 batch for this graduates. So basically, this is complete placement solution. Means what we are covering in this particular course. So we are covering all the things. All the things means what? The course, like syllabus, all the syllabus, recorded sessions we are providing for the quant, reasoning, verbal ability, and obviously we need to cover the coding. And let me tell you, we are covering the coding in the multiple languages, not only in Java, C++, Python as well we have included. And what we are providing the extra benefits like practice sets, live, obviously live classes. After whatever we are taking the live class, then also we are providing the recorded lecture of that. Okay, and suppose if any important topic has been left, then we are providing the recorded lecture as well. Okay, live classes, recording old batches also you will get it. Interview preparation content, company specific courses also we are providing. And apart from these, mock test series we are providing. English communication, those who are like weak in their communication will get help from this sessions. AI tool workshop we have included, and also live classes, recordings, old batches and the current batches. Everything you will get this in this particular batch, Achievers 2.5 batch. Okay, so don't think only Infosys will cover. No, all the remaining exams like TCS, Cognizant, Wipro, like whatever the exams, all the level of the problems we have covered in this session. So basically new batch we have started from the like after 4th Jan of in the new year, that is 2026. I hope everyone excited. Okay, so this is all about this discussion. So let's start our focus on main thing, the first problem. So let me tell you, this is medium level problem. This is medium level problem. The problem statement is subarray sum equals k. So some people might find this particular question as easy. Yeah, I admit that. But some of the people will not find it as easy. If you are saying, see, the brute force solution is easy. Okay, I will tell you everything. First, let's read out the problem statement. Given an array of integer nums, okay, we have nums integers and an integer k we have also. Fine. Return the total number of subarrays whose sum equals to k. Okay, and we already know what is subarray. Subarray is nothing but it's a contiguous non-empty sequence. Non-empty sequence of elements. Non-empty it is. Okay, not the empty subarray. Okay, within an array here. Got it? Fine. Let's see the example. So we have nums array 1 1 1 k is equal to 2 and the output is 2. And then second example, nums is 1 2 3 k is equal to 3 and the output is 2. So let's see how the output is coming. So let's take this particular example. Suppose we have this nums array 1 2 3, right? So what we need to do? First, we need to count the total number of subarrays whose sum equals to k. So the brute force approach will come inside our mind, will be like, first let's calculate all the subarrays of the given array, and one by one I will calculate the sum of each subarrays and we will match whether the sum of this first subarray is equals to k. If it is equal, then we will increase our result count. Getting my point? Because we need to count. So let's see, let's do step by step. So what are the subarrays for this given nums array? So basically I am talking about the brute force approach. And obviously this brute force approach will not pass all the test cases if the input size is larger. Okay, fine. Let's see. What are the subarrays for this nums array? So starting from 0 index. So 1, okay, then 1, 2, then 1, 2, 3. Got it? So basically these are the 3 subarrays starting from 0 index. 0 index means from the first element, right? Okay, so starting from first index, what will be the subarrays? So 2, then 2 comma 3. I hope everyone knows how to calculate subarrays. Okay, so 2 comma 3, that's it. And starting from second index, what will be the subarrays? 3, I think only this. Okay, so means these are the subarrays like 1 2 3 4 5 6. Now, but we need to count the total number of subarrays whose sum is equals to k. We need not to count all the subarrays. So let's count the sum. for this subarrays. So there is only one element, the element is 1. So if I am going to do the sum, I will get 1. For this, if I will add 1 plus 2, then it will give 3. If I will add all these elements, 1 plus 2, 3, 3 and 3, 6. Okay. And for this example, k is equal to 3 now. Just say this. So let's calculate for the first sum of all the subarrays. So here 2, here 2 plus 3, that is 5, and here 3. Right? Now we need to find out all those subarrays whose sum is equal to k, that is 3. So here we are getting 3 and here we are getting 3. So what is the total number of subarrays whose sum is equal to k? Only 2, 1 and 2. So that's why in the output it is returning as 2. Got the question, everyone? Question is easy. Like brute force approach is very easy. First, we will calculate each subarrays one by one. Suppose we have find out the first subarray, then immediately I will calculate the sum. Then immediately I will check this sum is equal to k. If yes, then I will increase the count. Got it? Similarly, I will calculate the second subarray, then I will calculate immediately the sum. Then again immediately I will check whether this sum is equal to k. If yes, then I will increase the count. So this is the approach. So let me write the brute force pseudocode for this brute force approach. Okay, so basically the first thing, I need to maintain the count variable int, count variable, because we need to return count, right? And also, so for the first thing, suppose we have this array now, 1, 2, 3. This is our nums array. So we are going to traverse. Okay, so let's traverse. I is here. For int I is equal to, I am writing the pseudocode, that's why I am not writing int. So int I is equal to 0, I less than n. What is n? N is the length of this nums array. So here in this case, k is equal to 3 and n will be also how many numbers of elements in the nums array? That is 3. Okay. Then I plus. Basically we are traversing. Why? We are trying to find out all the subarrays, and we already know how to find out all the subarrays with the help of two for loop, that is nested, right? Okay, so this one right now I is here, so this particular value will be the subarray right now. So the second, so let's initialize the sum variable with 0 because we need to calculate the sum for each subarray. So I'm going to use the another nested loop, that is j is starting from I, j less than n, j plus plus. Got it? So j is also starting from here because the single element can also be a subarray. Okay. Then after that, we will calculate the sum. So from I to j, listen carefully, from I to j means only this. Okay, from I to j only this subarray. Now I am going to calculate the immediately sum. So sum is equal to sum plus nums of j. Okay, after calculating I will increase j. Okay, so I have calculated. Immediately I will check whether this particular sum is equal to k. If it is, then I will happy and I will increase our count. So I will do count plus plus, that we need to return now. Getting my point? Then after that j will increase here, right? So from I to j, the another subarray, that is 1, 2, it will calculate the sum. Then again immediately it will check whether sum is equal to k. If yes, then it will increase the count, right? And the last, simply we will return count variable. That will be our answer. So basically this is pseudocode for the brute force approach. Got it? So can anyone guess what will be the time complexity? Just comment in the comment section if you got this time complexity for this pseudocode, for this brute force approach. So let me tell you, the time complexity will be order of n square. Obviously, right? Because nested loop, see, approximately n time, and this also approximately n time will execute. So this is nested one. The time complexity will be order of n square. For every I, j will traverse the whole, like from I to j, whole the array. So space complexity here we are not using any, I think, space. So just ignore that. So the time complexity is order of n square. Got it? Now, when you will go to submit this particular solution, it will, give TLE. It will give TLE. So this solution will not be accepted. Maybe some of the test cases will pass, but all the test cases will definitely not pass. So we need to think differently. Okay, so let's see how can we do. So let me add another page. Yeah. So now we are going to discuss the optimal approach. Optimal approach. Okay, so just see this. So let's consider our nums array is this. Already we have 1, 2, 3. So basically the optimal approach will be we are trying to reduce the time complexity in only one traversal. I need to find out our result, that is count total number of subarrays whose sum equals to k, right? So how can we do it? So basically we are going to use prefix sum plus hash map technique. Let me tell you how can we use this. Okay. Sorry. So this is our nums array. So obviously we need to count the total number of subarrays. So definitely we will create a count variable. Okay. Initialize with 0. And also let's calculate, let's define one variable, that is sum, that is sum. Every time we will be adding, like every time we will be calculating the prefix sum na. So initially it is 0. So let me create here hash map also. See, if you got this, then definitely you will able to write the code easily. This is our map, and map name is map I have kept. So we already know in map it consists of key and value. So in key, what we are going to store? So basically in key we are going to store prefix sum. Whatever the sum will contain prefix sum, I will store. And how many times this particular prefix sum is coming, that is frequency, I will be storing in this value. Getting my point? If you are not getting, no need to worry. I will dry run, then definitely you will get it. So the first thing, we are going to traverse this given array. So you can assume I is here. Okay. So I is, okay. So I is here. Fine. So the nums of 0, this is 0, na? 0 index, first index, second index. So nums of 0 is 1. So the sum will nums of I plus sum, like we are just adding this particular value. So 0 plus 1, that is 1. So right now the prefix sum is 1. So how many times? Then after that, let's see. After calculating the sum, but before that we need to do one thing. What? I will not do right now. I will let you know later. So right now sum is 1. Then after that I will calculate. See, we have k is equal to 3. Just keep in mind. Then after calculating the sum, then we will calculate sum minus k. Listen carefully. Listen carefully. Sum is right now 1. K is 3. Sum is right now 1 and k is 3. So 1 minus 3, that is 2. So after calculating the sum minus k, I will check in the map whether this particular value, that is sum minus k, is present in our map. So right now map is our empty. Right now map is our empty. Right now. So how can we say? So if the map is empty, so we can't say minus 2 is present in our map. If it is not present, listen carefully, if it is not present, then we will add, we will put the prefix sum into the map. See, the same approach I am going to follow. Okay. The prefix sum is right now 1. So 1. How many times right now it is coming? Only one time we have. Right now? Got it. Then after that, I will increase. Just see the dry run. I will increase the right now the current value is 2. I am going to add into this. So 1 plus 2, that will be 3. So right now sum is 3. Then again we will do the same thing. Sum minus k. So sum is 3, k is 3. So 3 minus 3 is 0. Now we will check. 3 minus 3, that is 0. 0 is present in our map. No. 0 is not present in our map. But, just see this. From 1 to 2, this particular subarray is valid. We need to count because this particular subarray, if you will add, so I am getting 3, that is equals to k. So we need to increase the count in this case. Right now, so basically when we are creating map, initially we need to put prefix sum is 0 and which is coming only one time for the empty subarray. So getting my point? Like why I am putting 0, 1 into the map initially after creating the hash map, we are putting map dot put 0, 1. What is 0? 0 is initially prefix sum is 0 for the empty subarray, and how many times it is coming? One time. Getting my point? Now if you check 3 minus 3, sum minus k is 0. So we will check sum minus k is 0. Is it present in our map? Yes, here. So I am happy. If it is present means we got the valid subarray. Means which is equal to k. Whose sum is equal to k. If it is present in our map then. Okay. So that's why sum minus k is 0. Na? Getting my point? Okay. So 0 is present in our map. So in that case, we will increase our count. So let's increase our count. So how many times 0 is coming? Corresponding value is 1. So this value, listen carefully, this value I am going to add in our answer, in our count. Got it? That's it. Let's move I ahead. So, okay. So after that, we have updated our count. Then after that, right now, prefix sum is 3. Then also we need to add. Now, because our map is maintaining prefix sum and frequency. So every time we need to add. Na? So 3 is coming one time, this particular sum. Okay. Now I is right now at the second index. Current value is 3. I am going to add. So 3 plus 3 will be 6. Then the same approach. Sum minus k, sum is 6, k is 3, 6 minus 3 is 3. So we will check whether this 3 is present in our map. Yes, it is present. Means we got another subarray whose sum is equal to k. Okay. So this 3 is present in our map. So I will be happy. I will add the corresponding frequency, that is value, in our count. So plus 1. This value I am adding. If here is 2, then I will add 2, not 1. Okay. So here 1. Got it. Then after that, the current prefix sum we need to add in our map because the map is maintaining the prefix sum. So 6 is coming only one time. Got it. Then I will move ahead. So now I is index out of bound. So we will stop. So that's it. So now you can see in the count variable it is containing 2. 1 plus 1, that is 2. That is our answer. That is our answer. Got it everyone? I hope got it. If you are not getting my point, just rewind the video and see the again. Watch the video again. Okay. So let me write here pseudocode. Then I will write on the lead code platform and I will see how to run after running the code. Okay. Whether it will accept or not. So let's see the pseudocode. The first thing, the same thing, we are creating the int count is equal to 0. Then after that int sum, let's create a hash map as well with sum. Initially it is 0 initialize with. Then we are going to create map. I hope everyone knows how to create map. key value in the both we are storing integer na. Just see this, in key and in value we are storing only integer, so that's why integer. Then here you can give any name of the map. Then we already know we need to use new, then has one. Basically this is syntax na. I'm not going to deep dive into this because everyone knows. So right, then after that, after creating the map, I already told we need to put initially map dot put 0, 1. Got it? Right now? Why I am putting initially? I already explained, right now? Okay. Then after that, pretty simple. We are going to traverse the given nums array. So definitely we have to use for loop for I is equal to 0, I less than n. So n is nothing but like, length of the array, then I plus plus. Okay. Then every time like we will calculate the prefix sum is equal to sum plus nums of I. Then after that we need to calculate the sum minus k. Just see this, sum minus k, right? After calculating the sum minus k, these values we need to check in the map whether it is present or not. So definitely we need to use if condition whether map dot contains key, whether the map dot contains key this particular value sum minus k. If it is present, then we will be happy. We will add in our count. So what we will add in our count? So I will add count is equal to count plus what? What value? The corresponding this value. Like sum minus k is this 3 na. So the corresponding value of 3 is 1. How can I get 1? How can I get 1? With the help of this key. So in map we will go there, map dot get 3 I need to write. What is 3? 3 is nothing but 6 minus 3. That is sum minus k. Sum minus k. Yeah, sum minus k. So it will get that particular value, corresponding value, and it will add into the count variable. Okay, and every time after checking in the map, every time we are adding this sum into the map. Every time na? So in the last line we will write map dot put every time this particular nums I, then and the corresponding frequency, like initially it is 0 na. If it is coming, then I will increase 1. If it is coming again, then I will increase again 1. So that's why we need to use map dot get or default method. Okay, so nums of, I hope everyone knows this. So basically not nums, here we are, see this, here we are adding the prefix sum na. Prefix sum means what? This particular value sum. Instead of writing nums I, we need to write sum here. Sorry for that. So here sum we will add, then map dot get our default. Initially it is 0. Every time if it is coming again, then we need to increase by 1. Yeah, that's it. And in the last you can simply return that our count variable. That is our result. Got it, everyone? This is pseudocode. So let's write on the lead code platform fast and try to submit. Okay. So the first thing, int count is equal to 0, int sum is equal to, I hope screen is visible to all, right? If sum is equal to 0, then we will create hash map of integer. If you are feeling the speed of the video is slow, so you can make it faster. Okay, no need to worry. So new hash map. Okay, so I have created. Initially we need to put map dot put 0, comma 1. Okay, then after that, we need to traverse on the given array. Int I is equal to 0, sorry, I less than nums dot length, then I plus plus. Okay, then after that, we will calculate the sum. Sum is equal to sum plus nums of I. Then immediately we will check in the map if map dot contains key, that is sum minus k. Hope you remember, sum minus k is present in our map. If it is present, then we will be happy and we will increase our count corresponding value. How can I get? Map dot get sum minus k. Okay, okay, fine. Then every time we are adding in our map dot put what? Prefix sum, the comma, map dot get or default, map dot get or default, the corresponding like sum, initially it is 0. If it is coming again, then we will increase the count, update the frequency, and in the last simply we will return the count. Okay, so I think we have completed. Let's try to run it. Oh, we did silly mistakes. Let me just see this. What is the compilation error? Int I is equal to 0, nums dot length, I plus plus. Okay. Oh, fine. So let's try to run it again. Let me see any another return count. Okay, we did something mistake. Let's see. Yeah, now it's accepted, right? So now let's try to submit it as well. So can anyone tell what will be the time complexity? If anyone know, just comment in the comment section. What will be the time complexity for this? Yes, order of n. Why? Why order of n? Since we are traversing here the nums array approximately n time. So the time complexity is order of n. But here we are using extra space to maintain the prefix sum and the corresponding frequency. So the hash map we are using now. So space complexity will also be a like order of n, we can say. Got it, everyone? I hope everyone got it. Okay, so now let's move to the next problem. Okay, so let's read about these. Let's read about the problem statement. Second problem that we have again. This is also a medium level problem. Okay, just see. Subarray sums divisible by k. See, the previous question, the same pattern, the previous question that we have solved just now, the pattern is same but slightly different. In the previous problem, we were calculating sum minus k, right? But here, slightly difference. What? I will tell you, and definitely you will be able to solve this particular problem with your own, and you will feel confident. Okay, just let's read out the problem statement. Given an integer array nums, okay, fine, an integer k, return the number of non-empty subarrays that have sum divisible by k. Okay, now we need to count the non-empty subarrays, total number of non-empty subarrays whose sum is divisible by k. But in the previous problem, whose sum was equal to k. This is the difference, key difference, right? Right now, we already know the subarray is nothing but it's a continuous part of an array. We already know, right? So, just see the input, then we will try to dry run and we will see. Fast, we will do the fast, okay? So, nums array we have this and the output is 7. How? So, we already know how to calculate the total number of subarrays using nested two loops. We already know now. So, the brute force approach will be very simple. First, we will calculate all the subarrays one by one, and after calculating each subarrays, we will calculate the sum of every subarrays. Then again we will check whether this particular sum is divisible by k. If it is, then we will increase our count. Got it? So basically this is brute force, and obviously this brute force solution will not be accepted. So definitely we need to think another optimal approach. Okay, just see this. So these are the multiple subarrays in the explanation. There are 7 subarrays whose sum is divisible by k. You can see 0 is also, obviously 0 is divisible by k. 0 is divisible by 1, 0 is divisible by 2, 3, 4, whatever. So if you add 4, 5, 9, 9 minus 2, 7, 7 minus 2, 7 minus 3 is 4, then 1, 5. So if you are adding, then we are getting 5, and obviously 5 is divisible by k. So that's why it is valid subarray for this case. So the brute force solution will look like this. I am directly going to write. Okay, I hope everyone got it. So the brute force solution in the same way. The first thing, int count, initially it is 0, and also let me see the previous. Yeah, then after that we need to traverse in the given nums array for I is equal to 0, I less than n, I plus plus. Okay, and here we are defining our sum, because for each subarray we need to calculate the sum. So again we need to use j starting from I. So here I am not explaining too much. I hope everyone knows, just I am writing too fast just to cover up this brute force solution. So the first thing, we will calculate the sum. Sum is equal to sum plus nums of j. This is the simple previous approach I am writing. Then after calculating sum, we will check if this particular sum is divisible by k. If it is divisible, means the modulus operator will give the remainder as 0. Means it is completely divisible. If it is completely divisible, then we will increase our count. Got it? And in the last, we will simply return the count. That's it. This is our brute force solution. Right? And what will be the time complexity? Just comment in the comment section immediately. Order of n square. And the reason is obvious. Here we are using 2 loop which is nested. Got it, everyone? Now again I am telling you, this particular solution will not be accepted. Whenever you will go to submit this particular solution on lead code, it will give TLE. Okay, if the input is large size. Okay, so now we are going to discuss the optimal approach. Okay, optimal approach. The same approach, what? Prefix sum plus hash map. But here, instead of storing the prefix sum, here we will store the remainder. Okay, here we will store there is slightly difference from the previous question. Here we are going to store remainder with their corresponding frequency in the map. Okay, so let's do the dry run, then we will get the better understanding. So let's create it here, our nums array. So what is the nums array? So let me write it here, 450231. So 450 minus 2 minus 3 1. Okay, and the k value is 5. The first thing, the same approach, the same pattern we are going to follow. The first thing, we will create a hash map. And just now I told, instead of storing the prefix sum and the corresponding frequency, we are going to store the remainder and the corresponding frequency, like how many times this particular remainder is coming. Okay, the same approach. First, we will calculate count is initially 0. Right now I is here. sum is initially 0. The same thing, initially in our map I am going to put map dot put 0 comma 1, means initially the reminder is 0 and how many times it is coming? One time initially. Okay, so right now the current value is 4. I am going to add in our sum variable, then it will become 4. Okay, then after we will check sum modulus k, because in this we need to calculate the remainder na. So remainder is equal to sum modulus k, it will check. So right now sum is 4, k is 5. So we already know this is modulus operator. Here 4 modulus 5 will give 4. Got it? The remainder will 4. So now we will check whether this particular 4 is present in our map. No, 4 is not present in our map. So if it is not present in our map, means we did not get any valid subarray that is required for our answer. Got it? Then what we will do? Whatever the remainder came, I will add in our map, because we are maintaining remainder and their corresponding frequency. So 4, how many time right now? 1 time. Got it? Now I will move ahead. Current value is 5. 4 plus 5 is 9. Then again we will check sum modulus k. Sum is 9, k is 5. So 9 modulus 5 is what? The remainder will 4. Right? 5 1 5, the remainder will 4. Now we will check whether this particular 4 is present in our map. Here we can see clearly, yes, it is present. We are happy by saying that we got valid subarray. But the question is, how many times? The corresponding value will decide how many times the total number of subarray we got. The 1. So we will increase the count with this 1 plus the corresponding value of this remainder, that is 1. Got it? And whatever the remainder that we have calculated for this I is equal to 1 case, remainder is 4, we need to put in our map. We need to put. So basically 4 is already there. So we can't put again 4 and coming 1 time. No. Because 4 is already there. So I will increase. I will update the corresponding frequency. I will increase by 1 because 4 is already present. 4 is now right now coming again. So I will update the frequency by increasing 1. Got it? I will increase here. So sum will become 9 plus 0. That is 9. Again we will do the same thing. Sum modulus k. 9 modulus 5 because k is 5. Right? So the remainder will 4. Now again we will check. So 4 is present in our map. Yes, 4 is present in our map. So how many times? 2 times right now. So I will add this particular 2 in our count variable. Got it? Not every time we are increasing by 1. Whatever the frequency is there, we are adding in our count variable. Got it? Fine? Okay, let's move ahead. So that the current value is minus 2. So 9 minus 2 will become 7. So again we will check 7 modulus 5. So 7 modulus 5, remainder will be 2. So 2 is present in our map? No. So 2 is not present, so I will not update our count. So then listen carefully. I haven't updated this for 4. So after adding 2, we need to update, we need to add this particular remainder in our map. We forgot. So 4, we need to add in our map, but 4 is already present. So we need to increase the count. Getting my point? Okay. Now, for this case, remainder is 2. 2 is not present in our map, so we will not increase our count. Just simply, we will add in our map. 2 is coming right now 1 time. I will move ahead. So 2 minus 3, sorry, 7. Sum is 7. 7 minus 3, that is 4. Again, we will calculate 4 modulus k. So 4 modulus k means 4 modulus 5, that is 4. Now, again we will check. 4 is present in our map. Yes. How many times? 3 times. So 3 times I will add in our count. Got it? And now the 4 is coming again, so I will add in our map again, but 4 is already there, so the corresponding frequency I will increase by 1 with the help of map.getOrDefault method. I hope everyone aware about this topic concept. Okay, I will move ahead. Sum will become 4 plus 1, that is 5. Okay, now again we will calculate 5 modulus 5, that is sum modulus k. It will give 0 as a reminder. And just see this, initially we have put 0 comma 1, now it is coming useful. So 0 is present in our map. Yes, 0 is present in our map. How many time? 1 time. So I will add the 1 in count, and this particular reminder also in our map. So 0 is already there, so I will increase the frequency. I hope everyone got it. Now I will increase, so index out of bounds, so I will stop. Whatever the count variable is storing the value, resultant value, that will be our answer. Just count it. 1 plus 2, 3, 3 plus 3, 6, plus 1, 7. That is our required answer. Just see this. See the example. The 7 is our output. Got it, everyone? Now let's try to, like, what's the code will look like this. How? Just say this. The first thing, like, let me write it here, pseudo code. The first thing, the same approach, the same steps. First we need to define the count variable. Int count is initialized with 0. Okay, and the sum is 0. And here we are creating a map. Okay, map integer comma integer, map name, then new hash map. Everyone knows I am not writing, this is a kind of pseudo code. Okay, I will write on the lead code platform itself, no need to worry. Okay, then after that, simple. After creating map, we will add map.put 0 comma 1. Got it? Then after that, for, so basically we are traversing the given array. Int I is equal to 0, I less than n, I plus plus. Then every time we are calculating the sum and sum modulus k, right? The 2 steps every time. So nums of I, and we are calculating the remainder every time. Int remainder is equal to sum modulus k. Got it? And after calculating this, we are checking if this particular reminder is containing our map, like map dot contains key, this particular reminder. If it is present, we are happy by saying that we got this array. So we will increase the count. Corresponding frequency, how can we get that? Map dot get with the help of this reminder. Got it? And every time we are adding, we are putting in our map, like map.put the reminder, and we are updating the corresponding frequency as well. So map.getOrDefault reminder comma 0 plus 1. I hope everyone knows this syntax. Every time I am using. So we like many times I have covered in our batches in the online courses. Okay, so that's it. And in the last we will return count. Simple. Okay, so but here one thing is missing. Can anyone get? One thing is missing here. Pause the video and think what is missing here. So that's why the main reason is to take this particular problem is one edge case. Definitely everyone will be missing. What? Just pause the video and think. If you got it, just comment in the comment section. So the logic is, see, this coding will work, but do you think, like, did you think, like, if the reminder value will become negative, in that case, what will you do? Just see this. Every time here we are calculating the reminder, we are getting the positive, either 0 or positive. But what if the reminder value is negative? In that case, what will happen? In that case, what will happen? Just say this. If the reminder is negative, that we need to handle the case So for this, see, we already know basically if the reminder is 0, so the modulus operator in Java, like in Java, C, C++, the modulus operator will give the negative value. Right now, like modulus can give negative value. Right or wrong? Modulus operator can give like reminder negative value or not? Yes, can. So that's why we need to handle. But we know that, let me change the color, but mathematically reminder cannot be negative, right? But mathematically modulo value always give like it always lie, let me write always lie between 0 to that particular number minus 1, right now this will be the reminder in mathematics, but in Java, C++, in programming it can give minus, so we need to handle separately this particular case, right? So we already know here k value is 5 na, in our example. So what will be the possible reminders? Can anyone think? Possible reminders. From 0 to, obviously from 0 to k minus 1. So reminder can be equal to 5. No. In our case, it cannot be equal to 5. So that's why it can, reminder can 0 or k minus 1 till k minus 1 in between. So in mathematically it is fine. But what if modulus operator is giving negative value? So that's what we need to handle. So after calculating here, we need to add a case. What? This edge case. Like if reminder is less than 0 after calculating the reminder, then we will update our reminder with the help of that k value. Basically we will add reminder is equal to reminder plus that k. That's it. This particular case we need to add. Got it, everyone? This is the case we need to handle. I hope everyone got it. Why we are handling this. Got it? So let's write this particular code on the online, like on the LeetCode platform itself. Just say this. The first thing, we need to define the count variable. It is initialized with 0. Then int sum is equal to 0. Then map we will create has map integer comma integer map is equal to new has map. Okay. Then after creating the map, just simply put map dot put 0 comma 1. I hope everyone understood why we are putting this. Then after that we will traverse int I is equal to 0, I less than n. What is n? Nums dot length. Nums dot length. Then I plus plus. Then we will calculate the sum. Sum is equal to sum plus nums of I. Then after that, immediately we will check the reminder. Int reminder is equal to sum modulus k. Got it? And here we need to handle that particular case. If like reminder value can be negative, just now I explained. So reminder if it is negative, then we need to handle by adding the k. So you might, like if you are still confused, just take the example of that in which reminder value is k, like no not k, reminder value is negative. Then after adding k, how it is handling, then definitely you will get it. Just think about one example like in which the reminder value is giving minus. Then after that, after calculating reminder, we are going to check in the map. So if map dot contains key, this particular reminder, if it is present, we are happy, we will increase our count, like we will update our count. map dot get with this reminder corresponding value of the reminder. Got it? It can be 1, it can be 2, it can be 3 based on the frequency. Then every time we are updating, we are maintaining the reminder. So reminder and map dot get our default method. Reminder initially is 0. Whenever it is coming first time, then we will add 1. Every time if it is coming again, we are updating the frequency. Yeah, that's it. Then after that, in the last, we will return this count, return count. I hope we have completed. So let's try to run it. Yeah, accepted. Let's try to submit it as well. Yeah, accepted. Can anyone tell what will be the time complexity for this? The same. The brute force solution was order of n square, but here we are using only one loop, right? So order of n, but here we are using extra space to maintain the remainder, that is map. So we can say the time complexity is order of n and space complexity is order of n. But here order of k will be the space complexity. Just think about it. Why? Basically the minimum of n comma k will be the space complexity. So but interview you can say order of k. Why? Because the possible value of the remainder will 0 to k minus 1. Got it? I hope. And also we are maximum, like in map, in map the maximum keys will be, here we are storing reminder, so maximum key will be around k. That's why we are saying order of k. So this is all about this problem. I hope everyone got it. Okay, so now let's solve next problem. Okay, so before moving to the next problem, let me tell you again about our Achievers batch. So basically the Achievers batch is going to start from the 5th Jan. Let me tell you again, from the 5th Jan. Okay, so what we are providing the features? So features are very, like, all of the scenarios, all of the content that are required, we are covering in this particular batch. What? So basically we generally teach from the scratch to the advanced level. So all of the sections like quant, reasoning, verbal, coding questions, everything. For everything we are providing the recorded lectures, we are providing the weekly classes, live classes as well, and practice it, mock test, and everything. Okay, and repeating the same thing again, all the same features. Okay, everything you will get it. Fine. And if you're thinking the previous batch, like the live sessions that is missed by you, so you can watch later as well. The recording will be available for you. Okay, so don't forget to join this. Definitely you will find it useful. Okay, and particularly I am teaching Java for this course. Okay, in the new batch that is starting from the 5th Jan 2026. Fine. So okay, so let's move focus to the our main problem. So the next problem is house robber. House robber, as the name itself suggesting, we are going to rob something. And so basically on the lead code, the problem name is like this, but when you go on the GFG platform, then you will get this name of this problem. Okay, so the problem name is different, but the problem is same basically. So we will try to understand. So basically before telling the solution, let me tell you, this is dynamic programming. This is medium level problem, DP problem. Okay, so this particular problem, like in Apple, in my interview I'm telling, in Apple already asked. Maybe in other companies already asked, but in my interview, this questions already asked in the live, like in the interview, not the online test, in the interview. Okay, so actually when the interviewer asked this particular problem, it was not like, they didn't mention that this is the house robber problem like that. They create a story for this particular problem. They create a scenario, but the logic, the same thing. The same problem was there, but the telling, the approach, the story of the problem was different. That's it. Okay. Okay, fine. So let's focus on our main agenda to solve this particular problem. So you are a professional robber, fine, planning to rob houses along a string. Okay, in a string there are multiple houses, so we are planning to rob those houses and we want to become karodapati. Okay, so each house has a certain amount of money stashed. Okay, and in every house there are some amounts. The only constraint stopping you from robbing each of them is that adjacent houses, just keep in mind, this is the main thing, this is the main thing, this is the main thing, houses have security system connected. Okay, so means it will automatically contact the police if two adjacent houses were broken into on the same night. So means at a time I can rob one house, but the second house, the immediate second house that is adjacent, I can't rob. If I will go, then automatically it will connect to the contact the police. So it will be dangerous. So means we can't rob the adjacent house. Just keep in mind. So let's read the next line. Given an integer array nums, fine, representing the amount of money. So we have this nums array, just say this, and each value, each element is representing the amount of money of each house. Fine. What we need to do? We need to return the maximum amount of money you can rob tonight, just keep in mind, in one day, without alerting the police. Okay, so tonight we have to rob without alerting the police, means we can't rob the adjacent house. Just keep in mind. Let's see the example, then we will get the better understanding. So we have this nums array, 1 2 3 4. So let me create it here. 1 2 3 4, 1 2 3 1, not 4. So this is our nums array. Just think, how can we make more money without robbing the adjacent house? So suppose right now I am standing it here, so I have two choices. Right now I am at here, so right now I have two choices. Either I will rob it. See, I don't know what like how much money this particular house contains initially. When I will go into the house, then I will be able to know, na? So I have two options. Either I will rob it, this particular first house, or I will skip. So first house means, so this 0th house, 0, first, second, third, because the array index always start from 0. So this is house number 0 is containing 1 CR. House number 1 containing 2 CR. House number 2 containing 3, and house number 3 is containing 1 CR. CR means crore. You can assume anything amount. So right now I'm standing at the house number 0. I have two choices. Either I will rob, either I will steal, or I will escape. So suppose I am going to rob it. So I rob it, then I got the money 1 CR. Fine. Then I will move ahead. Then I know I can't rob this second house that is adjacent. If I will go, automatically it will contact the police. I will be in danger. So I will skip this. Then I will go here. Right? Again, I have two choices. Like I can go or I can't go. Like I have two choices. Either I will steal or I will skip. So suppose if I am stealing, if I am robbing this particular house, then I will get 3 CR. Okay. Then definitely if I am robbing this particular house, then I can't rob this. Right now? So in this case, we are getting 4 CR. Fine. So let's see any other way to get, like any other way to rob the houses. Yes. Suppose we are skipping the first house, that is house number 0. Then we are going to rob this. If I am robbing this, then I am getting 2 CR. Then the next I have two choices again. Like I can rob or I can skip. But if you are going to rob this, then automatically it will contact the police. So I can't rob. Okay. So here again I have two choices. Either I will steal or skip. So if you are going, but I need more maximum money, na? So I need to like I need to steal. I need to rob. So in this case, 2 plus 1. So we are getting 3 only. So in this way, so now you can see here we are getting 4, here we are getting 3. So which one is the maximum amount? This one is the maximum amount. So output is 4. Getting my point? So the explanation is saying rob house 1. Okay, that is money 1. This one. And then rob house 3. 3 means this one. Money is 3. Then the total amount you can rob is 1 plus 3, that is 4. That is our required answer. Got it, everyone? Question is clear, I think. Any doubt? You can ask in the chat section, in the comment section. Okay, fine. So let's see the next example if it is there any. Yes, in the second example, let's see. Just see, we have 27931. So again, just think the same thing. Okay, so before, okay, what are the possible ways? So we have two choices. Either I will rob it or I will skip it. Like either I will steal or skip. If I am going to steal means rob, so I will get 2 CR. Then I can't rob because otherwise it will contact the police. So I will be in danger. So I will skip it. So again I have two choices. Either I will take or I will skip, right now. So if I am going to rob it, then 9 CR I will get. Then I can't rob this. If I am going to rob it, then I will get like this 1 CR. So means 2 plus 9, 11 and 12 CR we are getting. So is there another way? Yeah, there are multiple ways. So if you are thinking just skip the first house number 0. Let's take the house number 1. Let's rob the house number 1, that is 7. So I will get 7. So I can't rob because otherwise police. Then then again I have two choices. Either I will skip or I will steal. So if I am going to rob, then I will get 3. And if you are going, like if you robbed already, then you can't rob this, right? So otherwise police. So this one is the another way. So like this, there will be multiple, right? 7 plus 3, but we need maximum money also. So skipping will not be good. Simultaneously, if you are skipping, if you are going to skip, that will not good the approach, because we need maximum money also, right now. So if you see, here we are getting 12, here we are getting 10. Obviously, the 12 will be our answer because we need maximum money. Just see this. And you see the explanation, rob house 1, that is money 2. Okay, this one. Then rob house 3, that is money 9. Okay, and rob house 5, that is this one. House number 4, that is money 1, that is 12. So total amount you can rob 2 plus 9 plus 1, that is 12. I hope everyone got the question, right? If you still doubt, you can ask in the comment section. And still you have, like, if you're not getting reply, you can ping me on LinkedIn as well. On the first slide, I have already mentioned my LinkedIn account. Okay, you can connect me on LinkedIn. Fine, any doubt you can ask me on LinkedIn. Whenever I will get time, definitely I will respond. Fine. Okay, so let's try to think, how can we solve this? Can you think, suppose in the street, suppose there is only one house. If there is only one house, then what will you do? Then you will go and rob it. Simple. Because if there is only one house, so there is no any adjacent system, there is no any police will call, right now. So police logic will not be applicable if there is only one house, because the police will automatically contact, like it will contact the police automatically if we are going to rob 2 houses simultaneously, adjacent houses. But here only one house, so means we can go and rob it. That will be our amount, that will be our result. Hope we are getting my point. So this is the base case basically. So this is the base case. So let me write it here. If, So we can write like this. This is the base case, like if only one house, if only one house, so then means if, so in code we can write like this, if n is equal to 1. So what is n is nothing but the length of the nums, means n is equal to nums dot length basically. Okay, so if n is equal to 1 means if there is only one house, then we will simply return that money. One house means what? This is the our array, simple, that is zero index na. So this value, whatever this value will be there, I will return, I will take that particular money, I will return to my home. So that is nums of zero value, return nums of 0. Got it? I think till here it's fine na? If there is one house. Okay, just think now. So basically this is DP problem na. So how can we do? So this is the base case, like in this case no need to create DP, because if there is only one house, no need to create DP. Okay, so now what we are going to do, we are going to create DP array. Int, we already know how to create DP, like this, new int. In Java we already know n plus 1 size. So n is the original, but here we are creating n plus 1. Why? Can anyone tell in the comment section why we are creating n plus 1? I will explain, no need to worry. So here we are creating n plus 1 size. So basically let's think that particular example 1 2 3 1. Suppose this is our nums array. So then again here we are going to create DP array of the size n plus 1. So here 0 1 2 3. N is here 4 because 4 houses means nums dot length. So here we are going to create DP array of the size 5 n plus 1. 1 2 3 4 5. Got it? 0 1 2 3 4. So basically if we are creating like this, so each box what it will represent. So basically here DP array we have created na. So exactly what it is representing. So basically DP of I is representing the maximum money that you can rob, that can be robbed from first house, first ith house, first I houses. So what does it mean? So basically suppose this particular box, what it will tell you, it will represent the maximum amount of money that you can rob from the ith houses. Ith houses means till first houses. Okay, so this particular box will represent this one. This particular box will represent how much money, that is maximum money that you can rob from the ith house. I value is here 3, but means 3 houses. From the 3 houses, the maximum money, how much, like maximum money that you can rob. So in the last box, what it will represent? So it will represent the maximum money that you can rob from the 4 houses. Okay, so the answer will be here our, because in the question in nums array there are 4 houses. So this particular box, what it will represent? This particular box will represent the maximum money that can be robbed from the 4 houses. Getting my point? So basically our target is to fill this DP array, and the last value DP of 4 I will return, that will be our answer. Okay, if you are not getting, no need to worry, just think. Till here it's fine. This is the base case, like if and there is only one house, that particular value I can rob from the 0th house because there is only one house. Okay, can anyone tell what this particular box will represent? This is DP of 0, means this box will represent DP of 0. This box will represent the maximum money that can be robbed from the 0 houses. I value 0, na? So can I just think maximum money that I can rob from the 0 houses? Means if there is 0 house, how can I rob? What will be the amount? What will be the maximum money? 0, na? Because there is 0 house. So here I will keep 0. So basically DP of 0 will be 0. Reason is clear, because 0 house. There is 0 house. Okay. Just let's think about what we can fill in DP of 1. DP of 1 means what? Maximum money that can be robbed from the one house. From the one house means only one house. So what I can feel here, like what we can feel here? We can write, if there is only one house, so I will go and I will rob. Simple. One house means what? Only this particular house will be there. Na? So means nums of 0 value I can get maximum. So in DP of 1, in DP1 nums of 0 will be there. Got it? So nums of 0 value is 1. So once here I can get maximum money. Got it? Now just think, in this box what it will represent? This box is representing the maximum money that can be robbed from the 2 houses. From the 2 houses means from the 2 houses till here. Just see this, from the 2 houses. From the 2 houses. Okay, so just think how much money I can rob it. We have 2 choices. Like whichever the maximum I will rob, na, because there is only 2 houses, na. Whatever the maximum I will rob it. Simple. Like either you can, basically for each house we have 2 choices. But just keep in mind the police will not contact. So the current value is 2 and the previous value is whatever the maximum, that will be our answer, because only 2 house. So here 2. But just think, how can we write in the code? So basically we have 2 choices, like either I will steal or I will skip. So if I am going to steal, then means I will get that value, I will get that particular money, that is 2, right? Plus till here whatever we have robbed, right? Because the previous one I can't rob because that will be adjacent, right? Na? So till here only 0. So means if you are not getting this, just skip it. Let me tell you again. I can get you. Just say this. If I'm going to just see this, let's try to fill this particular box, then you will get it the better logic. So this particular box I'm going to fill. What does it mean? This box is representing maximum money that you can rob from the 3 houses. I values 3, na? From the 3 houses. From the 3 houses. We have 3 houses, means till here. Now till here. From the 3 houses, the maximum money that you can rob. Just think. How? So we have 2 choices. The current house is this, na? We have 2 choices. Either I will steal or I will skip. If I am going to steal, listen carefully. If I am going to steal, then the current money, the current house money is 3 plus then till here, till first houses, like till here, till first houses, whatever the maximum money that we have collected, we will add. Means this money till first houses, this box is representing, na? Because we have third house, I have 2 choices, either I will steal or escape. If I am going to rob the third house, so that money I will take, and till the money from the first houses, till the first house's money. So means from here to here. So 1. So basically that will be 4. And then again the second step is skip. Either you can skip the current house. If you are going to escape, that means you can't take the 3 crore. 3 CR. So means, so till here means for the till first house, from the first house whatever you got the maximum amount, that will be our answer, because the current we are skipping, that's why. Okay, so means uh, so basically, okay. Just see this from here to here, that money, because the current house money I am skipping. I am skipping the current money, current house money. So means DP of this previous value, that is 2, means till second house whatever the maximum value that I have, I will take that. So that is 2. Getting my point? Getting my point? I hope. If you're not getting, just rewind the video and definitely you will get it. So basically we have two choices. If I am going to steal, then we will have 4 CR. If I am going to skip, then we will have 2 CR. So what is the maximum? Maximum is 4. So I will take 4 here. Got it? Just see this. Let's try to fill this. Okay. So now this particular box is trying to say maximum money that can be robbed from the 4 houses. From the 4 houses. 4 houses means till here to here. Till here. From the 4 houses. Okay. Fine. So again we have two choices for the current house. Either I will steal, listen carefully, either I will steal, let me write it here. Okay, so either I will steal or I will skip. So we have two choices for the current house. If I am going to steal the current house, then the current money, that is 1, I will take. Okay, so the current money, that is 1, current money is 1. So how we are writing this? How we are writing this? This is DP of, what is the value? This is nums of 3, but we are, I value is 4. Listen carefully, I value is 4, but we are taking this value, current house value, that is nums of I minus 1. I am relating that because I value is 4. I am taking the current house money, okay, plus until second house, listen carefully, till second house money, that is 2. That is 2. Till second house maximum money, because the previous house I adjust, and that will be adjacent, so that's why. So till second house means this 2 is representing the maximum money. So 2. So basically 2 is coming from this DP of I minus, this is I4. So DP of 2. DP of 2. 2 means I minus 2 because I is 4 right now. So I am relating, I am trying to find out the expression. Okay. And if you are going to skip the current house, this one current house, then simple. Just the previous, like if I am skipping the previous value, whatever the maximum till now we have, that is 4. So means 4. So basically this is DP of I minus 1, that is 4. Getting my point? So what is the maximum? 1 plus 2 is 3 and here 4. So 4 is the maximum, so it will 4. That's it. Got it? So basically I deliberately dry run it because to get this expression. Whatever the maximum I will take, that will be our answer for this particular box, and in the last we will return. So in the code will look like this. Till here it's fine, DP of 0, DP of 1, right now? Okay, so till here we can fill the manually, but from here to here we need to run a loop. So for I is equal to 2 to I less than till 4, till 4. So basically this is the n plus 1 size, so I less than n plus 1, I plus plus. Okay, so in the same way, like we have two choices, either I will steal or I will skip. So we will define two variable, either I will steal or I will skip, right? If you are going to steal the current house, then the current value, current money, current house money I will take, that is nums of I minus 1. Keep in mind, I am not writing I. Why? Hope you got it from this. When we were going to fill this is I, but we are taking this current house, that is I minus 1. Here I is 4, then I minus 1 is 3. Got it? Fine. Nums of I minus 1, if you are going to take the current house value and then they skip the previous to previous value till that, means dp of I minus 2 till the that particular house, the maximum money. Okay, and if you are going to skip the current house, the previous maximum high, that is dp of that we are storing in our dp I minus 1. That's it, simple. And whatever the maximum I am going to put in our dp, है ना? dp of I is equal to whatever the maximum of this two, still or skip, because we have two choices. That's it. And in the last we will simply return the last value dp of n. And why n? Say this, here n is 4 for this, so n is 4, so the last value will be 4, not n plus 1. Just keep in mind, if you are doing n plus 1, then it will become 5, which is not the index. So that's why dp of n, the last value. Got it everyone? I hope it's clear. If not clear, then you can ask me again, no need to worry. Fine. So now let's try to just write on the lead code platform and try to submit it. Okay, and till then just think what will be the time complexity for this, and you can comment. Okay, fine. So the first thing, if first let's create the n variable for this. Int n is equal to nums dot length. Then suppose if there is only one house, means n is equal to 1, then return nums of 0. Got it? Then after that we have created dp of the size new int of the size n plus 1. Oh, why n plus 1? I didn't explain this. Why n plus 1? I think you got it, because just see this. Why n plus 1 size I have created dp? The reason is, what is the possible value of I? And just now I explained what is dp of I. dp of I is nothing but the maximum money that can be robbed from the I houses, right? So similarly, just think, what can be the possible values of I? It can be 0, it can be 1, like it can be 0 house, it can be 1 house, it can be 2 house, or it can be n house, right now? Getting my point? So including 0 to till n, listen carefully, including 0 to till n. So definitely we need to create the dp of the n plus 1 to include all these, including 0 till n. Getting my point? That's why n plus 1. I hope it's clear, because we are including 0 house as well. We are trying to representing the 0 house. If there is 0 house, then what will be the maximum money that we are including? That's why. I hope it's clear now. Okay, so we have created, let's try to fill dp of 0, means if there is 0 house, then definitely the money will be 0. If dp of 1 means if there is only one house, then nums of 0, because only one house. Fine. Okay, then after that, for the remaining we are going to traverse with the help of array, like with the help of for loop. I is equal to 2, I less than n plus 1, because the dp array we need to fill, then I plus plus. The same thing, two scenario for the current house, either I will still or I will skip. So if I am going to still, then the current house value, how can I write? If you are writing nums of I, that is incorrect. We need to write I minus 1. If you are going to rob the current house, then I will take that money and the previous, except the previous to till previous. Hope you are getting my point. So that maximum value we need to take, that is I minus 2. Just relate with the that particular array. Okay, so int skip the second one, like either I can still or skip na. So if I am going to skip the current house, so means till the previous house, whatever the maximum amount that I can rob, we will take, and that is represented by dp of the previous, like I minus 1. I hope got it. Then whatever the maximum I will take, I will put into the dp. So dp of I will be the math dot max steal comma skip. Fine. Okay, yeah, so we have filled the dp, and in the last, that is dp of what, this thing, dp of n, correct, not n plus 1, because n plus 1 will become index out of bound. So dp of n will be the our answer, because n is equal to 4. So dp of 4, what it will represent, it will represent the maximum amount that can be robbed from the 4 houses, because we have 4 houses in this street. Okay, I think we have done it. Let's try to run it. Just see whether, yeah, accepted. Let's try to submit it as well. Yeah, accepted. Can anyone tell, just think, what is the time complexity? It's pretty simple. It's pretty simple. Can anyone tell? Yes. Order of n. It's simple, na? The time complexity order of n. We are traversing each and every house once. And space complexity is also order of n. Got it, everyone? Till it's fine. Okay. Now, let's solve the next problem. Okay, the next problem is house robber second. See, it's a similar problem of the previous one that we have solved just now, but it's a slightly different. Like there is some extra condition that is given in the particular question. So this is also a DP problem, medium level problem. You can see on the lead code platform. Okay, so but the first question, if you got it, then definitely you will solve it within a second, because we are going to steal that previous code for this problem. Okay, so but here's slightly difference. Let's read out the problem statement. You are a professional robber planning to rob houses along a street. Okay, each house has a certain amount of money that we already know. Stas, all houses at this place are arranged in a circle. Here it is slightly twist. All houses at this place are arranged in a circle. Fine. That means the first house is the neighbor of the last house. Getting my point? The first house will be the neighbor of the last house, because all the houses are arranged in a circle. Okay. So meanwhile, adjacent houses have a security system connected. We already know, and it will automatically contact the police if two adjacent houses were broken into on the same night. So means the first house is the neighbor of the last house, right? So means the first house and the last house is also adjacent. We can't rob. If I will go, then police automatically, it will contact the police, right? So I will be in danger. So the first house and the last house is also in the adjacent. Just keep in mind. So that's why here it is saying arranged in a circle. So this is the main thing that this question is different from the previous. Okay. So given an integer array nums representing the amount of money of each house, return the maximum amount of money. Okay, you can rob tonight, only one night. Okay, without altering the, like, not altering, without alerting the police. Okay, the question is same, but here is slightly twist that all the houses are arranged in a circle. Got it, na? So let's see some example and let's try run. So nums here is this 232. So you can assume, suppose this is circle, this is circle, na? So suppose the house number 2 is here, then house number suppose 3 is here, then again 2, means this one is adjacent, this one is adjacent. Got it? So similarly, just think this 1 2 3 1. So 1 2 3, then again 1. Okay, so like this you can think. So just think, how can we get this 3 value as output? How can we get this 4? Let's take this particular example 1 2 1 2 3 1. Okay, just think, this is our nums array. Okay, this is our nums array. Now again we have two choices, either I will rob it or I will not rob it. So we can't, these two I can't rob it because these two are neighbor. Like anyone we can rob, na? But can't simultaneously because these are adjacent. Hope you are getting my point. So this is the similar question of the previous, but what we are going to do is we will see these are the first one and the last one houses adjacent, na? So we need to skip either first, because these are arranged in a circular. So I will skip the first house or I will skip the last house, means there will be two cases. The first case, if I am skipping the first house, the remaining houses I will do the robbing. I will take the same approach for the previous question of the previous question. The first case, I am skipping the first house. Then for the remaining houses, I will do the same thing that I did for the previous question. Then second case, I will skip the last house, and for the remaining houses I will use the same approach of the previous question. And so means there are two cases, and whichever is the maximum will return, I will return that value. Getting my point? So let's do this. So okay, just say this, if I am going to skip the first house, so our array will look like this. Suppose so for this we are going to make two array. The first one is skip first array. As the name itself suggesting, I am just giving the meaningful name. Skip first array means like this 2 3 1, means we have skipped the first house, right? And then I will create skip last array. Means 1 2 3. So 1 2 3 I have taken, I have skipped this last house. Got it? So means we have this array and we have this array. In the previous question also we have one array, right? So the same approach we are going to use. So the same method that we have written in the previous question I will use for this array, then I will use for this array. So this will return some result 1, this will give some result, some other result, that is result 2. So I will store in these two variable. Like this we can write just whatever, like result 1 and result 2, and whatever the maximum I will return that will our answer. Getting my point? Just think. Now the question is, suppose we have created these two arrays, skip first array and skip last array. Obviously we can create, na? And we already know how to create int skip like that. Int in Java, int skip first, then new int of the size n minus 1, nums dot length minus 1, because we are skipping the first element. And similarly we will create like this, int skip last is equal to new int. n minus 1 because we are skipping the last. So after creating, we need to fill the elements now. So we can fill like this: for int I is equal to 0, I less than n minus 1. Why can anyone tell why n minus 1? So basically, in the skip, just see this: skip first of I is equal to here. So we have this now: 1 2 3 1. So right now I is here, so here we need to fill 2. So means we need to fill 2, that is 0, that is 1. So at the 0th place I need 0 plus 1 value, 0 plus 1 value, that is I plus 1 value of the nums. So nums of I plus 1, that is 2 I need to write now, then 3, then 1. So that's why I plus 1 value I have to take, because the ith value we can't take, right now. Similarly, in the skip last of I, what we can, here I need I, like this one. Suppose I is here, right now I is 0. So at the 0th place I need 1. So that is here 0, that is nums of I. It's simple. So we need to skip the last now, so that's why I have written n minus 1, less than n minus 1. Getting my point? I hope you got it. So we have created these two arrays and we have filled with these elements. Got it? So we have all the elements in skip first and skip last. And then similarly, I will call the same method that we have written. Suppose the method name is rob helper. Okay, in this method we will pass this array skip first array, and this method will give some result. So let's say result1, int result1. Similarly, I am going to call the same method again. I am not going to explain this method, the same approach that we discussed in the previous question. So in the same method, I am just passing the second array, that is that we have created skip last, and definitely it will give some result. So I am storing in result2 variable, and whatever the maximum I will return. So we will write like this: return math.max result1 and result2. That's it. Got it? Now then in the next line we will define this rob helper method, because both are same. Here rob helper method we will define the same thing that we have written in the previous question. I hope got it everyone, right? So let's try to directly write the code on the lead code platform. So we will copy this code now, otherwise we will make some changes as well. Okay, fine. Just say this, the same thing, like if first let's define int n is equal to nums dot length. Fine. If there is only one house, the same approach. If n is equal to 1, then return nums of 0. If there is only one house, I think till it's fine, right? Okay, then simple. We will create two arrays: int skip first, new int of the size n minus 1. Fine. Similarly, we will create skip last array is equal to new int n minus 1. Got it? Then after that we will call the method. First we need to fill na? Okay, so for int I is equal to 0, I less than, just now explain, n minus 1, because we need to skip the last value as well. So I plus 1. So skip first of I is equal to nums of I plus 1. Got it? Then skip last of I is equal to nums of I. Okay, till it's fine. Then after filling, then I am going to call a method. Let's suppose rob helper method, it will return some result. So for the skip first array, so rob helper method, spelling is okay, that's helper. Okay, and here we are passing the skip first array. Okay, then again we will write int result second, int result 2, calling the same method again, and here we are passing skip last. Got it? And whatever the result, like result 1 and result 2, whatever the maximum we will return, that will be your answer. So return math dot max result 1 comma result 2. Fine. Now one task we left, like we need to define this rob helper method. So out of this method we are going to define the same code. I am going to write like int public int, let me erase. Okay, so public int rob helper method, and here we are passing this skip first or skip last. So we can give any variable name. So let's take it in general, int array. Okay, fine. Like nums we can't take because already in the question we are already given. So int array and okay, so let's copy that code instead of writing. Okay, okay, so instead of writing here we have given array, so you can write arr right now. I think done. Any issue? I don't think so. So if there will, we will solve it. So let's try to run it. Yeah, accepted. I hope it's clear. Let's try to submit it as well. Yeah, accepted. I hope got it, everyone. So any doubt, if you have, you can ask in the chat section. If it is not clear, then again you can ask me on, ping me on LinkedIn as well. Okay, till it's fine. So we have discussed 4 questions. Like all the questions are not easy, obviously. Above easy, you can say medium. And also let's discuss one more problem, that is hard level. Okay, let's solve the hard one problem of the today's session. So let's read about the problem statement first. So binary tree maximum path sum. So basically it's a hard level problem. Okay, so this is very like crazy problem. Just see this. A path in a binary tree is a sequence of nodes. So basically it is trying to make you understand what is path. So path in a binary tree is nothing but it's a sequence of nodes where each pair of adjacent nodes in the sequence has an edge connecting with them. Okay, if you're not getting, no need to worry, I will take example and I will dry run, I will explain again. So a node can only appear in the sequence at most once. Obviously in the path, one node will appear at most one time. So note that the path does not need to pass through the root. Like it's not mandatory that the path that you are find out, it should pass through the node. It's not mandatory. Okay, because we need to find out the maximum path sum. It can either go through the root node, it cannot be. Okay, so it's not mandatory like the path should go through the root. It's not mandatory. So the path sum of a path is the sum of the nodes value in the path. Okay, given the root of a binary tree, so we have given a root of binary tree, we need to return the maximum path sum of any non-empty path. So we need to return the maximum path. So that path can pass through the root node or not. Okay, it's not mandatory that it should pass through the root node. It's not mandatory. So maximum path we need to find out either from the left side, either from the right side, or only either through the from left to right, or only right, or only left, whatever the maximum that we need to take. Just see the example, then we will got the what are the cases that we can draw. So just see this. Suppose we have this. So suppose we have find out like this path from here to here, here to here, here to here, like this. So means 2 plus 1 plus 3. So means 2 plus 1, 3, 3 and 6. So this is the maximum path sum, right? So we have added. So this is our answer, right? So this path we have found out. So that is the maximum path sum. So just keep in mind why I'm taking this example, and just make you understand the path, how the path will look like. So like this. Okay, so this is our answer. Got it? Fine. And the path is also there, like only this path from here to here, then 2 plus 1. Then in this case only 3 is the sum, and this is also path 3 1. Then in this case only 4. Sum is 4 na. So but we need maximum, so obviously we will define maximum variable. Okay, and we will maintain. Okay, no need to worry, whatever the maximum we will maintain in this particular variable. Okay, so this is the maximum, so that's why for this. So basically in this example, this is the maximum path only, this one. Okay, maximum path sum. Let's see the another example. So case 1, like another case, let's discuss. So in this case, let's see, suppose the same path we are going to take like this from here to here to here. Then the sum will look like this: 3 plus minus 1 plus 0, then 2. Okay, any another path, other path? Yes. So let's take only this from here to here. So means 3 plus minus 1. So in this case 2. Okay, let's see this path from here to here. In this case 0 plus minus 1. So that is minus 1. So okay, what is the maximum till now? Till now is maximum 2. But say this answer is not 2. So means there is another path that we are missing. Okay, any other path? Just see this. Whole path we have taken already, and this left side path sum we have already taken, right side path sum we already taken, and also we have taken from left, like from left through node to the right side also, but still we are not getting the maximum sum. So means we are missing something. So basically, if suppose only we are taking this node, only 3, in that case only this path, only single node, so in this case the sum will be 3. So only we are taking only 0, so in this case the sum is 0. So only if we are taking this particular node, then minus 1. Which one is the maximum? So you can directly say 3 is the maximum path sum. So that's why output is 3. Got it? I hope it's clear. So our path can be a single node value as well. Got it? So that's what I was trying to explain. Just see the next example. In this case, the same thing we are going to think. The path can be like this from here to here, right? So in this case, -2 plus 100 plus -3. So 3 to 5 minus 5, 100 minus 5, that is 95. Okay. Let's see this path from here to here. So in this case, -2 plus 100. So in this case, we are getting 98. Okay. So just see this path, -3 plus 100. 100 minus 3, that is 97. Okay. So till now we are getting 98 is the maximum, right? No? But the answer is 100, means we are missing something. So basically, if we are taking only single node, this one, root node only, you can say root node only. So in this case, 100. So if you are taking -2 and -3, so these are the obviously minimum values. Na? If you are taking -2, -3, these are the minimum. We are not getting maximum path sum. So basically, 100 is the maximum if you are taking only root node, only this path. Got it? That's why 100 is the output. I hope got it. Fine. Right? Let's try to build the intuition to solve this problem. Just think. There will be multiple cases. I want to make you understand what are the multiple cases. Means multiple path sum. That can be our answer. Or from that path we can get our answer. Just say this. The first thing, suppose I am standing it here. Right now I am it here. Just think, I am it here. Okay. So from the left side, just see this. From the left side, suppose we got some, like from the left side through the node, through this node, then from the right side. This is left side, this is right side. We got a sum. Let's assume, I am assuming. So just now I explained the multiple paths. So this path, maybe in this path we can get the maximum sum, right? From the left side, maybe we can get the maximum sum. From the right side, maybe we can get the maximum path sum, right now? So that's why we are assuming. So suppose like this curve we got. So means the case number 1. From left side and from right side. We got, like from left side and from right side we got the good sum, like maximum sum, not the negative. Okay, and then we are adding the root value as well, from left, from right, and also we are adding this. Maybe this can be maximum path sum, right? Now this can be our answer. This is the answer. Maybe, like, this is not, but it can be. Na? So means we got the answer from left, from right, and also the root node. Got a good answer or good sum, you can say. So means in this case we can write like this. So we can write like this. Expression will look like this: left side plus right side plus root value. Got it? Root value. Okay. This can be our answer. Means this path here to here. Okay. Let's think another path. Case second. It can also possible you are getting from the left side this thing. Let me change the color. From the left side, you are getting a good sum. Okay. And then you are going to add this root value. This is also possible. Or from the right side we are getting good sum, then we are going to add the root value. This is also possible. Whatever the maximum I will take. Whatever the maximum I will take. So we can write like this. Whichever. So for the right also it can possible from right side. So whatever the maximum I will take. Right now. From the left side, from the right side, whatever the maximum I will take, then I will add the root value. Getting my point? So this is another case. So we will write like this. Case second, whichever is good, either in the left side or either in left side or right side. So we will take right side sum. So we will write like this. Whatever the maximum sum we are getting in either any side, like from the left or from the right, whatever the maximum I will take, and then we will add the root value. Okay, so we will write like this: the maximum of left side path sum or right side path sum, either anyone will take, na? So that's why maximum plus, then we will add the root value. Getting my point? Root value. Okay, so let me put in the box, other it will fall down. Okay, fine. So this is the second case. Any other case? Just see this example. In this case, we are discarding the left path, we are discarding the right side path sum also, because we are getting the negative values from the left side, we are getting the negative values from the right side as well. So only we are taking the root value. This is also a case. Getting my point? So this is another case. So in the case number third, so means from the left side we are getting many number of negative sums, and from the right side also we are getting the negative values. So this will not good, na? Only maybe this one can be good, that is root value. So we will write like this: neither. So which one is the case? Neither left is good, neither left nor right is good. Okay, let me small it. Okay, fine. So in this case, which one is good? Neither left is good nor right is good, means from the left path sum we are getting negative values because we need maximum. From the right side, right path, we are getting the negative value sum. So means we are taking only root value. So means in this case we are taking only root value. Fine. So these are the three cases. Now these three cases are fine. So basically just see this first case again. In the first case, can we return this particular expression from the recursion? Just see this. From the let's discuss the case first. The path will look like this, right now. From the left side we are taking, from the right side also we are taking, and also we are adding the root. So our path will look like this. So means we got our answer. So can we return this value to the upward side like this? Return? No, because this is only curved, this is twisted. Already we got the sum from the left, including root, from the right also. So we got the path. So we can't move upward. Getting my point? We can't move upward side, right? So we can't return this particular expression in the recursion. Reason is clear why we are not returning this particular. So this is the answer, one of the answer. It can be like maximum answer. So for that we are here defining the maxsum variable. I will update accordingly with this value. Whichever is the maximum I will take. Whichever is the maximum in all the three cases I will take. Got it? Fine. So case one is path is look like this. So this is not valid path. Na? Well, this is the path valid, but we can't return at the upward side because it is already completed. From starting from here to here, we can't return the value upward side. Got it? So we will not include this expression in the return statement. Just let's discuss the second case. Second case, either the left side will good or the right side. Right now, so our path will look like this. Either the left side will good and or right side will good. There will be two paths. Like we are taking, but we are taking only one, either left side or right side. But including the root node also. See this, whatever the maximum we are taking from the left or the right path sum, and also we are including the root. So here we have two cases. Either we are taking this or this, whichever is good, whichever is the maximum we are taking. So this path, from this path we can return. Just see this, from the left side we got path sum including the root value, this node value, current node value. Then whatever we got the sum, we can return to the upward side. Obviously we can return, na? Whatever we are getting till here sum, we can return to the upward side. So this expression we will add in the return statement. And similarly for this, from the right side we are getting a path sum including this current node. Then whatever we are getting sum, we can return to the upward side. So means like this is valid, this is valid, so we can return. So in this case, either this one or this one we will take including the root value, and we can return to the upward side. So means this expression will include in the return statement. Till here it's fine, na? Logic is clear. Just see that third case. This path, which path we are talking? Neither left nor right, means only root value we are taking the root value. After taking this root value, this current value, it can be root or something, current value, current node you can consider. This current node we can return, na? Obviously we can return to the upward side. So this expression will also include in the return statement in the recursion. I hope it's clear. So basically means we will define this max path sum or max sum variable to maintain the max sum overall sum. So means case 1, case 2, case 3, whatever the maximum, so we will write like this. So whatever the max sum, so first we will calculate case 1 first, then second we will write case 2 in the code, then we will write case 3, then we will try to find out our max sum. How? Whatever the maximum of all the fours, like first we will, all the three cases, first we will take the same variable, that is max sum, and all the cases like case 1 comma case 2 comma case 3. Got it? Whatever the maximum, it will store in the max sum variable. Okay, so basically case 1, case 2, case 3, these are the expressions. So in the return statement, that is most important part, in the return statement what should I write? So already we need maximum path sum. So just now I told case 1 no, only case 2 maximum of only case 2 comma case 3. Just now I told why case 1 is not included in the return statement, because this is not valid now. We are starting from left path sum, then we are taking root, then we are going to the right direction, right path sum. So this is complete path already. We got a answer, like that can be answer, we got a value, we can't return because this is complete path here from here to here, like that. Got it, I hope. So this is the pseudo code. Now I'm going to code on the lead code platform itself. Fine, just see this. If you doubt, you can ask. Okay, so this is hard level problem, binary tree maximum path. So the first thing, let's define global variable, private class level variable, private max sum. Okay, So you can write like the base case. What will be the base case? Like suppose we are going to make a solve method, another solve helper method. So in that case, what will be the base case? If the root value is null, in that case we will return null, right now. So the first thing we will write max sum. Suppose there is a method, but before that we need to initialize that maximum. So here we have defined this particular variable. Now we need to initialize. We need maximum sum na? So let's initialize with integer dot minimum, because we need minimum value. Okay, till it's fine. Then after that we are going to call a method, helper method. Let's suppose solve, and here we are passing our root. Then in the last we will return our sum, maximum. Okay, maximum. Now let's define this particular solve helper method. Just see, public, private, it depends upon the requirement. Okay, so let's write private int solve, then root, that is tree node root. Okay, fine. Just now I told in the solve method, like what will be the base case? If the root is null, then if root is null, then return 0. Means there is no node. How can I find a path with the maximum sum? We can't. Okay, till it is fine. Then after that we will calculate for the left path sum, then for the left side, for the right side. So int left is equal to, we are going to call the same method int solve root dot left. Got it? Similarly, int right is equal to solve root dot right. Till it's fine, right? Then after that we discuss 3 cases, right? So let's write one by one. Case 1 in the comment, case 1, like the same thing, like we got the answer in from the left side and from the right side, including the root. Okay, so case 1, in case 1, so let's take in the variable name int path value, path through node value, something like that, path through node. Just think about that particular figure, path through node, this one, left side, root, right. Okay, is equal to, just now I told, like from the left, from the right, and the root. So we will write left plus right plus root val. Got it? Then second case, case second. So what is the second case? Just see this, whichever is good, either in the left side or the right side sum. So I will take either left side, then root value, or right side, root value. So whatever the maximum I will take, then we will take the root value. So we will write like this. So any variable name int, so max single side, either this or this. So we will write max single side sum, single side, max single side path is equal to, so we can take maximum of left or right, right now. So math dot max of left comma right. Okay, then we will add the root value, root dot val. Why we are writing root again and again? Because here we have passed root na. Here if you are passing node, then you will write node dot val. Like whatever the variable here you have passed, we are using. Okay, so this is the second case. Third case, Case third. What was the third case? Just see this. Neither left is good, neither right is good. Like from the left side path, we are getting the negative numbers. We are not getting maximum, not good sum. From the right also, if you are taking only root value, that is node value, then we are getting a good sum, right? Maximum, which can be maximum. So this is the third case. So only node value can be good. So we can write only node value, or you can write only root value. Like here we are using root, so we can, like, this is variable, it's your choice. So only node value, that one. So root dot val. Fine. This is all the three cases. Then after that, what I told, I have maintaining a max sum path. So whatever the maximum from all these cases, we will take and we will update our max sum path. So simply we will write max. So let me change the line. Sorry. Max sum is equal to math dot max. So basically it's Java. So every time we need to check from this and this, which one is the maximum. From this and this, which one is the maximum we need to use. So math dot max, the same variable first we will take the max sum. Then again we will use math dot max from these two. From these two means what? Path through node and then again we will use math.max for these two variable, whichever is the maximum we will take. So math, so basically we are taking the maximum of all. So this is basically a syntax, math.max of these two, comma, only node value. Control Z, Control C, and then Control V. Got it? I think it's fine. Yeah. So whatever the maximum of all the three cases and also taking its self value, that is maximum, it will update overall maximum. Then the most important part that I told, what we will return. Just now I told, just see this. What we will return? Maximum of case 2 and case 3. This case 1 we are not returning because it's self answer, can be answer. That's why this will not include in the return statement in the recursion, because this is, just see this, from the left side going through the root node, not root node, it can be root node, going through the node and from the right side like this. So that's why, just see this. So we will write math.max case 2 and case 3. So case 2 value is max single side path. So let me write, copy it here, comma, then only node value, Control C, V, right? I hope we have completed. So let's try to submit, let's try to run it first. We are getting any issue? Okay, so max private maximum. Okay, so here we didn't give any data type. We need to give private int maximum. Let's try to run it again. Yeah, accepted. Let's try to submit it as well. Yeah, perfect. 100%. Okay, perfect. So I hope everyone got this problem. This is a hard level problem. This will check your thinking level as well. Like, what are the possibilities of path that you can think? Got it, everyone? If you have any doubt, you can comment in the comment section. So before summing this class, so let me tell you again, this is our achiever batch. Just now I explained what are the features and what are all the content that we are covering in this particular achiever batch. So basically, if you go inside this content, then you will get it. The recorded videos, quant, reasoning, verbability, coding questions. So basically, let me tell you again, the coding questions are taught in the various programming languages. Not only Java. On Java, in Java I will teach, like I generally teach in Java. So for the Java instructor I will be there, and for C++ other faculty is there, for Python is other faculty is there, like for all the programming language we are covering in this particular batch. Okay, so let me tell you, from the 5th Jan we are going to start this fresh batch from the scratch to advanced level. We are covering all practice set, mock test, AI tool workshop, English communication, extra these things also you will be getting. Okay, so this is all about the today's session. If you find it useful, just hit the like button and subscribe this to our channel. And if you need more, like more problem also before 4th Jan, you can comment in the comment section, and whatever the questions that I have asked, you should put in the comment section as well. So that's how we can make it interactive. Okay, so that's all about this today's session. We will meet in the next class. Till then, bye bye.